So Calabash released a video in which he claims a larger coil separates an unmask better than a smaller coil in general. I would like to examine that claim and look at the test he uses to make that claim and demonstrate why I think it's clearly wrong. Let's start with the question, what is iron masking? Iron masking is when there's both an iron object and a non-iron object under the sensitive parts of the coil at the same time. For example, a nail and a coin. If the iron response is strong enough, the coin will be hidden and the machine will report iron. It's important to note that the electromagnetic field below the coil is a single entity, and the detector treats multiple objects interacting with that field as a single interaction, which is why iron can hide desirable targets and multiple targets tend to blend together. So if you recall from one of my previous videos, the double D coil configuration is most sensitive in this center strip, and the ring around it is also sensitive, but to a lesser degree. So when we have an iron target under the coil and a coin under the coin becomes hidden or masked. So Calabash is claiming that a larger coil is less susceptible to iron masking based on the results of a particular test that he conducted. Let's look at his test. So in his test, he puts two iron nails close to a coin and demonstrates how a larger coil can hit the target, but the smaller coil cannot. The assumption here is that this test represents an environment heavily polluted with iron. He says the smaller coil misses this target because of coil saturation. As far as I can determine, that's not a real term, and I cannot connect it to any real phenomenon within electromagnetism, so I don't really know how to address that claim. But I do get what he's trying to say here, and ultimately he's right. The larger coil will unmask better in this particular test. But let's ask ourselves, why is the larger coil winning in this test? Well, as we talked about, the double D coil is sensitive in the middle and on the outer ring. The closer objects are to the sensitive portions of the coil, the stronger the response they create. So as you can see here, the nails are in between the outer ring and the middle band on the larger coil, and there's this huge void for the outer ring to exist in. While on the smaller coil, the sensitive outer ring overlaps with the iron nails. So the larger coil does indeed win in this situation because the ferrous targets are not overlapping with the sensitive parts of the coil when the center band strikes the coin because of the way the targets are arranged. But the success of the larger coil depends on this void existing around these targets. Now we must ask ourselves, does this situation really represent heavy iron? Would a heavily iron polluted site have these huge voids around the targets? I would say no, because the implication of heavy iron is that there are small distances between targets and not a lot of empty space. And remember, the larger coil is only winning in this situation because of this void. So his assumption that this test is representative of heavy iron is false. A heavy iron situation would probably look more like this. The situation he is actually testing is a low target density environment in which a few targets happen to be close together. I'm not saying you won't encounter this situation in the wild. Odds are you will. But what I'm saying is that this test does not represent heavy iron because of this void, and this void is why the larger coil outperforms the smaller coil. So the premise, the initial assumption on which this test hinges, specifically that this is representative of a heavy iron environment, is clearly wrong. So when we are in heavy iron and we're trying to unmask and pick out desirable targets, what we're actually doing is playing a game of trying to find the correct orientation to sweep the coil such that as few iron objects as possible are near the sensitive portions of the coil when the center band sweeps over a desirable target. That is why if you are in heavy iron and you get a chirp, a high-tone chirp, it is essential that you investigate it by rotating 300 degrees around the object to see if there's any orientation that gives a clear, consistent tone. If there is, you should dig it. Now ask yourself, which coil size would you want to play this game of orientation with? A large coil or a small coil? Of course, common sense says that the smaller coil will be easier to maneuver in a crowded environment. In fact, it's basic probability theory. The larger the coil, the larger the electromagnetic field, the more likely it is for that large field to encompass multiple objects, thus creating an iron masking situation. The smaller the coil, the smaller the electromagnetic field projected into the ground, the lower the odds of there are being multiple objects under the coil at any given point. This is a provable mathematical fact. I mean this seriously as a mathematician who specializes in probability theory. You can think of the grass as a probability space and the coil as intersection between that space and the probability density function that defines the target distribution when integrated over the surface area of the coil. Thus, the greater area encompassed by the coil, the greater the probability of targets commingling under the coil. Basically, the larger circle you draw, the more likely you are to encircle multiple objects. To suggest otherwise would be to say that a smaller circle has a greater odds of encompassing multiple objects than a bigger circle, which is provably false, and I mean this in very certain mathematical terms. So as I've shown, Calabash's test does not represent heavy iron, and the conclusion he draws defies common sense, logic, and probability theory. Now some caveats. Of course it's possible to make a bad enough metal detector such that the unmasking advantage of a smaller coil disappears. It still may be possible that the Deus 2 9-inch coil unmasks better than the 6-inch coil on the Legend of Equinox, because signal processing also comes into play. We all know of detectors that totally blow an iron regardless of the coil sizes. But the test he conducts fails to conclusively demonstrate that because of the confounding variable of how target configuration interacts with coil size, and that's not designed out of the experiment, while simultaneously he proceeds from a false assumption that the test configuration is representative of heavy iron. We can eliminate the variable of signal processing by using the same detector with different sized coils. For example, analyze the difference between the 6-inch coil and the 11-inch coil on, say, the Equinox. So that way the signal processing occurring is the same. And Calabash is right, metal detecting is a game of probabilities. But the larger coil makes a larger electromagnetic field and therefore has a greater probability of having multiple targets beneath the sensitive parts of the coil at any given time. Now, what I think is the most interesting takeaway from this analysis, and this is something new that I learned through this analysis, is that there are specific configurations that can only be unmasked with an 11-inch coil and specific configurations that can only be unmasked with a 6-inch coil. Both Calabash and I have demonstrated that. So at a minimum, we can conclude that to unlock every masked target at a location polluted with iron, you need to run as many coil sizes as possible across that area to capitalize on specific target configurations that just happen to give a benefit to a given coil size because of how the geometry of the situation plays out. The moral of the story is, when you get a result that defies common sense, defies logic, defies science and mathematics, we should be especially suspicious of that result because there may be another explanation for why it is occurring.